For the second part, we need to get the wetted length of the sample, solid sample under measurement. Because you know the sample is always in two halves, liquid part and solid part. So the contact angle is always between a liquid and a solid. If you change any of them, the contact angle will indeed change. So our solid sample actually will be this zinc strip. Actually, the solid sample will be my piece of rock, which is cut like this one, like any of these. But for our case, I'm using and demonstrating the idea using this zinc strip because it is non-porous, so it does not imbibe water. It is easier for cleaning and for dealing with it. It's more robust, it cannot break easily. And I need to find its wetted length. What is the wetted length again? When this is the surface of water and it goes in like this. So this rectangular cross-section here is the wetted length and I need to measure it. Once again, I'm using force tensiometer and I'm using the very same equation. Now L is unknown. Sigma, I'll pick a liquid of known surface tension if normal is as always given. So I need to get rid of this sigma C once again. So I need once again a perfect wettability as much as possible. So for a given solid, what do you expect a liquid to be used? Should it have a very high surface tension or very low surface tension? Actually, since I'm after good wettability, then it should be very low surface tension. And if you go back to our reference here, and see for this given temperature, for example, the same temperature, 22, which of these different liquids has got the minimum surface tension? Actually, it is N-hexane, which is 18.2, followed by N-heptane, which is 19.95. We will be using N-heptane because this is what we have available here in the lab. And I remind you that the water was about 72. And this is just to compare the relative values. Plus, being N-heptane is normal. It does not have branches, it's straight chain, so it is non-polar, which is very important, and it helps in reducing its surface tension. So the other vessel, which has been cleaned, I'll be using it with N-heptane and with this plate after cleaning it to measure its wetted length. So let's go. This is N-heptane. Again, about 50 milliliters. The vessel. So this is to be placed here in the second vessel. The zinc plate has been cleaned. This is zinc plate. After being cleaned, it's hooked up here. Remember, the zinc plate is like our piece of rock. It will never be exposed to flame. Flame is just for the standard plate. Okay. Now, we'll push it up as before to make it almost at the surface of the heptane. And then go here. I can lift this off now. If I'm in. We'll close the contact angle part. We'll open our database. This here. Here we have page 3022. Page 20. This is our first one. So now now we go to a new measurement. What do we need? Contact angle. No, we'll postpone contact angle for the third part. Now we need to go to wetted length. Name is the zinc plate. Wetted length. Solid is zinc plate. Liquid. Browse for it. It is in heptane. We click it because we need its surface tension value. The procedure is unchanged, and remember here, notice that the contact angle is assumed to be 0 because we have used a very low surface tension liquid. Otherwise, if you know a better or more accurate contact angle, please put it here. The vessel is correct and we are ready. Correct location. For the zinc plate, we go to here, start measurement. Similar as before. Fill the reference liquid into the vessel with minimum volume 45, we already have 50, and it's reference liquid because we do have not any liquid, but a liquid with low surface tension to be suitable for the condition that the contact angle is assumed to be 0, almost 0. Fix a sample at the balance, which is our case zinc, or maybe a realistic example, a piece of rock, and then move it up. Once again, unlocking the balance, setting the balance to 0, and then detecting the surface. This is a peep. And then it will start plotting few points. Earlier, the surface tension, the measurement was all done at the surface. Here, it will detect the surface and then will go deep into the liquid. And it will take points as it is going into the liquid more and more. So the liquid position, our position in the liquid, will be a new parameter, not just the force. So now we will have two values that are changing with one another. The force, which is always the case, and the position of the sample will be given as well. And each value corresponds to one position. We will use this as per given in your manual to plot it, one force against the position, and from there we'll be able to calculate the zero force, force at zero position, and from there we'll be able to calculate the wetted length as we'll see in a minute. Here the run is over. As you've seen, this is a straight line that the software gives us. Again, we'll copy all of this to our Excel sheet. We'll go to this second sheet and call it WL for wetted length. Now, we know we need to have the N-heptane surface tension value. I'll get it from here. I go to the liquid, and I have here the N-heptane. If you notice, the polar part is 0, so there is no polar part in it, which is good. And I read surface tension as 20.4 millinewton per meter. Then, as per the lab manual, I'll plot force against position and find the linear interpolation, or the trend line actually. So, this is the position, and this is the force. So I go to insert, scatter, I pick this one, for example, here. And then, for the data, I select on the vertical, I have the force. This is force versus position. So, force on the vertical, it's all of this, against position, the horizontal. We do it again. Y values, force, X values, position. position. And this is the case. Then I go to here, right click on the data points and add trend line. It is linear, yes, I need this type. Set intercept, no, I leave it. I put the equation, I need to know the equation and the R square, which is how good the bit is. I move it here. So this is the force on the vertical. This is the X, which is the position of the horizontal. This is the slope. I don't care about it much. It is a negative. That's why it's dipping down, which is okay. And this intercept here is the force at 0 position. It will be, force is in millinewton, and it will be this amount, which is 0.532. Then, from the equation, the wetted length is the force over surface tension. So, wetted length equals force, which is this amount, over surface tension, which is this amount. And this is given in millinewton over millinewton per meter, so this is in meters, which is equal to, I need it as millimeters, so I multiply by 1000. So this is 26 millimeters. So now after getting rid of N18 back to its graduated cylinder, I'm happy without the mask. So this is a caliper. I'm measuring the thickness with the help of Tony and the width of the plate to make it sort of a double check on the wetted length we have got from the experiment, and this is already there in your manual. So the thickness here is 0.25 millimeters. What about the width one? No, this is. Yes, this is the action.
12.68.
It is 12.68. And if I go here, thank you, it will be again 2 times the width plus thickness, and it will give me 25.86 millimeters, and what I got from the experiment using N18 was 26 millimeters, which is great. Okay? So this is the second part, and you are ready for the last and most important part, which is the contact angle.